Yeah.
Okay, 2 plus 3i squared. Some of these that we didn't get a chance to go over yesterday can be gone over. Yes.
I get her calculator. Sorry.
Okay, hang on, wait there. You're about to be on camera.
Smile.
Okay. Order of operations. What we have going on here are division and exponents. Which comes first?
Exponents.
Exponents, which means the first thing I need to do is FOIL the denominator.
This one's like a lot.
Okay?
Yeah, I don't like this one.
Squared there, though.
Pardon? I do not have the square there. Thank you, Michelle. That's correct. So now I'm going to have 5i over 4 plus 12i plus 9i squared. Did I FOIL that correctly?
Yeah.
Okay. And the plus 9i squared becomes minus 9. Since I squared is negative 1. So this becomes 5i over negative 5 plus 12i. Correct?
Yeah.
Okay. That's the first step. Now you're set up to actually do the division.
No, that's all you need to do.
Nope. Can't leave it like this. This is to find the quotient from here. What you have to do now is multiply top and bottom by the complex conjugate of the denominator. So what would that be?
Negative 5 minus 4.
Perfect. Exactly right, Matt. Multiply top and bottom by negative 5 minus 12i to get a real number on the bottom. You're not done with a quotient or a fraction or a division problem in complex numbers until there's no i's on the bottom. So I distribute on the top, and I get negative 25i minus 60i squared. Is that correct as a first step?
Yes.
And then on the bottom, this is my a plus b times a minus b factoring pattern. So that's going to give me positive 25 minus 144 I squared.
Yay.
Is this correct? Okay, Michelle thinks so. I squared is negative 1. I'm going to have 169 on the bottom. On the top, this is negative 25i plus 60, because I squared is negative 1 again. So my final fraction will be something like 60 over 169 minus 25 over 169i. Is that as simplified as it gets?
Wait.
Yeah.
Well,
Wait. Yeah.
You can't simplify 169 with 25.
Yeah, 169. 3 doesn't go into it.
Well, they can both be square rooted.
Yeah, but you can't. That's not equivalent. It's no. The a over b doesn't equal a squared over b squared.
Is it true?
So you can't just take the square. But yeah, these are both perfect squares, but that doesn't help us for simplifying. Good eye though. That could come in handy later. So that's your final answer to number 58. That one was just annoying, but it shouldn't have been any like brand new ideas or any other questions on the division ones. On the quotient ones. What did you do for number 50?
What did you use?
Number 50. That's not an example we went over yesterday. Negative 14 over 2i. How do you get the whole point of the complex conjugate is to get rid of the I on the bottom.
Multiplied by negative 2i, both sides.
Top and bottom?
They both.
No, just top.
Yeah, whatever you do with this one, you got to do to the other.
Oh, well then top and bottom.
Do you have to multiply? Well, think about the goal for a minute. Is there a faster way to get to that goal of getting a real number on the bottom?
Can't you just multiply by 2i?
How about just I over I?
Well, wait, why not just multiply by 2i, like 2i over 1?
No, you have to multiply same thing top and bottom. You can't multiply the top by one thing and the bottom by another. The whole thing is you can't change the value. Nothing we did, here's the horrifying thought. Nothing we did up here changed the value of this expression. We just made it so that it was in the standard form of a complex number. Okay, so you can only multiply the top and bottom by the same thing. Negative 2i would work. 2i would work. But the simplest one, if I just multiply it by I get negative 14i over 2i squared. What's 2i squared?
Times I is -1.
I squared is negative 1. So that becomes negative 14 over negative 2. And what's that equal?
It's -7.
Positive 7, I think.
No, I
Negative
didn't
to
see. I
negative.
didn't see that first. Sorry.
That's right. You could do it a longer way, but you should wind up with, negative 7i. I dropped an I by mistake.
You dropped an I.
I dropped an I.
Positive.
Positive
Are you
7i.
lying?
I said it wrong. All right. Yeah, so that's 7i.
You said my name on camera.
All right. Any questions on that one? Remember what the goal is. Normally, to accomplish this goal, you have to use the complex conjugate. But if you see a simpler way, why bother? Any other questions on this?
Can you do one of the problems from 42 to 48?
Sure. Write the complex conjugate of the complex number, then multiply the number by its complex conjugate. Okay, some of these are
Pain on the ass.
pain in the ass. Some of them are easier than others. Now, these were designed to make you think.
Yeah, I didn't want to think.
I'm going to do these in order and show the progression. May I get rid of this?
Yeah.
You may.
Okay, thank you. I appreciate that.
You're welcome.
Okay, number 42. First, a quick reminder. The complex conjugate of a plus bi is a minus bi, and this is the real component. This is the unreal component. Seems obvious to this. These are designed to mess with you a little bit on that. 42 is 7 minus 12i. What's the complex conjugate of 7 minus 12i?
7 plus 12i?
7 plus 12i. And it's going to follow your simple factoring pattern of a squared minus b squared.
49 and 144.
Yep, 49 minus 144i squared, which is going to become 49 plus 144, which is going to be 190. What is this going to be?
What?
184, 6, 193?
Yeah, that's true.
Is that right?
Yeah.
Okay, remember, if you multiply an imaginary number by its complex conjugate, you have to get a real one at the end. You have to finish with just a real number. 44. This is just uglier. Negative 3
Wait,
minus square root of 2i.
What cancels out the I squared?
The I squared is equal to negative 1.
Okay.
Because I is square root of negative 1. So I squared is square root of negative 1 squared. Square root and squared cancel, and you're just left with negative 1. I squared wanders from the imaginary back into the real. Real world, yes. Okay, what's the complex conjugate of negative 3 minus root 2i?
Would it be 3? 3 plus? Or no?
A doesn't change.
Alright, that's what I thought. Negative 3 plus square root of 2i.
Yep, negative 3 plus root 2i. Okay, so when I square the first, square the second, this becomes positive 9 minus, what's the square root of 2 times the square root of 2?
16.
2.
Or 2.
Oh, no, I thought you said 2 squared.
Okay, all right, that was, 2 squared times 2 squared would be
Yeah.
16. Okay, glad there was an answer for that. And then, so square root of 2i times square root of 2i is 2i squared. I squared again is negative 1, so that's just 11. Okay?
That's just
Wait. No.
Wait. What?
Oh, never mind.
Perhaps I should show the
Okay.
step.
The,
9 minus 2 times negative 1.
okay, but the problem said negative 3 plus 2i.
Did it?
Yeah.
Haha, so it did. Okay, let's pretend we started here and wrote this here, and it'll get the same answer anyway.
Okay.
Yeah, it won't change the answer, but good call. 46. Here's why 46 is really annoying. Okay, but I did do an example sort of like this yesterday. Square root of negative 15. Does that look like a complex number in standard form?
Sure.
Sure.
No.
By sure does mean no.
That's not